testing documents are available in the testing environment. So the first document we have the SRS. SRS is nothing but a system requirement specification. It is a Word document which defines the complete business functionalities of a particular application. So SRS is basically designed by the system analyst. Then we have the BRS, the business requirement document. It is a client initiated document which gives the requirement in their own format. Then it will be covered in the standard format by the software people can understand. Like in the BRS requirement document, it is a general document where the requirement will be divided into modules, and each module contains how many interfaces are screens like that. Like the architects given this document, like how your UI will be look like they give certain screenshot in this particular document. So BRS is developed by the business analyst. Then we have the FRS document, that is functional requirement specification, business requirement specification. Then we have the compatibility requirement specification, performance requirement, reliability requirement document, and at the last we have the configuration requirement document. So these are the some major documents which is available in the testing environment. Like in the FRS, we have the functionality. In the BRS document, we have the business requirement. In the CRS, we have the compatibility, like how compatible with the different operating system or the different browsers. Then the performance requirement document, like it gives you what should be the performance for certain load on the application. So we have the performance testing document for the performance. Then we have the reliability requirement, that is RRS. And at the last we have the configuration, like what is the system configuration for building this application. So let's take an example of testing document, that is low level design document, that we call it as LLD. LLD is a like detailing the HLD. It defines the actual logic for each and every component of the system. The class diagram with all the methods and a relation between classes comes under LLD. Program specification, that is covered under LLD document. Then we have the HLD document, like the high level design document. It is the overall system design document. It covers the system architecture and the database design. Let's see the test scenarios. So what is testing scenarios? The testing scenarios is basically needed by the tester to put his or her foot in the end user's shoe to check the performance of the action, like how they are using the application under test. So we create certain testing scenarios. In the scenario testing, the preparation of the scenario would be the most important part. To prepare the scenario, tester need to consult or take help by the client, stakeholders, and developers. So in the testing scenario, tester create the possible testing scenarios with different modules, and they verify with the client or the different stakeholders if they are working correctly. So let's take a difference between a test case and a test scenario. So test case consists of test cases like name, precondition, steps, input condition, and the expected result. But Test scenarios consist of a detailed test procedure. We can also say that is a test scenario has the many test cases associated with it. Like if we have created a scenario that can have multiple test cases, then the test cases are the low level action. It can be derived from test scenarios, but test scenarios are the high level classification that can cover the multiple module functionality. Then we have the test cases, that is a detailed document for the test case which help the execution of the testing. But testing scenarios means talking and thinking requirement in detail. Test cases are the set of steps which perform on the system to verify the expected output. But test scenarios is thread of the operation. It is not a step-by-step information to verify certain feature. Test cases is more important in the developer is happening at on-site and QA is happening offshore. So it will help you to understand both the developers and QA in sync. Like a tester create a test case and share with the development team. Test scenarios are more important when the time is right. Test cases is not sufficient. Like if you have less time, then you can just create the test scenario which can cover multiple test cases. Then we have the test procedure. Test procedure is nothing but a standardized and documented process for performing an experiment or conducting the evaluation. Like it is the procedure of your testing. Then we have the error seeding. It is a process of concisely adding the errors to the source code, which can be used to evaluate the amount of errors after the system software test phase. After adding the error to the source code, one can try to estimate the number of real errors in the code based on the number of seeded errors. So if we put certain error in the source code, so at the last we verify the real errors and count it with the seeded error. So how many errors we have seeded and how many errors are the real errors. Then we have the error guessing. So error guessing is nothing but a testing technique to find out the bugs based on the experience of a testing user, like testing profile candidate. Error guessing is testing technique that makes the users, testers, skill, intuition and the experience. So you guess certain errors beside, or you can say surround the particular module and find out the defects on the basis of your experience. There is no particular hard and fast rule for the error guessing, but it is certain when you are working from a long time in the application and based on your experience you find certain defect. So error guessing has certain techniques like you divide by zero, entering a blank space to the text field, pressing submit button without entering any value, uploading file exceeding the maximum limit. So these are the error guessing what you do based on your experience. We have certain more error guessing like how you can guess the error from your last experiences, your historical learning, your previous defects, your production issues. So on the basis of these scenarios, or you can say these points, you can work on your error guessing. The previous test result, risk report to the application, variety of your data used for testing. So these are the points on the basis of this you can guess your error. Like error guessing is dependent on these points. Then we have the test bed. Test bed is nothing but an environment. Like you create certain environment for your testing. The test bed consists of hardware, software, operating system, and a network configuration. Like web service should be IIS or Apache, database should be MySQL, operating system could be Windows or Linux, browser is IE or Firefox, and the Java version is version 6. So this is a test bed you have created to verify certain feature. Then we have the test data. Test data is actually the input given to the software program. It is the represents data that affect or affected by the execution of the specific module. Some data may be used to positive testing, some data is used for the negative testing, typically to verify a certain functions, or you can say produces a certain output when you are giving certain input. So test data you create based on your requirement document. So in this section we have seen several criteria of your testing like test data, test beds, test cases, test scenarios to see what is priority and what is severity in the testing. Priority determines how quickly the defect is fixed by the development team. Let's say we have the multiple defects with multiple priorities, multiple modules. So how soon developer can fix that particular defect with different priority. So priority we have high, medium, low. So how soon a developer can fix that defect. So the priority labels are critical, high, medium, low, that we called it as P1, P2, P3 and P4. Then we have the severity. Severity is the parameter to denote the implication of a defect on the system, like how this particular defect impacted on the application, how critical defect is and what is the impact on the whole system functionality. So if we fix this defect, so what is the behavior of the application, what is the impact on the application, and if we don't fix this defect, then what can cause us? The severity is the parameter set by a tester while we open a defect and mainly in the control of the tester. So the severity is set by the tester and the priority, because priority shows how soon that defect can be fixed. That's why it is set by the development team. So the priority is set by developer and severity is set by the tester. So the severity is critical, major, moderate and low. So severity says what is the impact of this defect on the particular application. So let's see different examples of priority and severity. So let's take an example of high priority and a high severity. So any defect by which testing cannot perform or testing cannot continue, so that comes under high priority and high severity, because that you have to fix, then only testing will continue. Like if you have any button, by clicking on that a certain functionality is not loaded or certain functionality is disabled. So that particular defect is high priority and high severity. Then we have high priority and low severity. Defect which have to fix but it doesn't have any impact on the application under this category. Let's say example like If you are expecting a particular error message to verify, then it has the priority high because error message should be verified. But the severity is low because that is not impacting on the application functionality. So that is why its severity is low. Then we have the high severity and low priority. So high severity is like the testing cannot continue, but the priority is low, like it is impacting on the system more, but the low priority, like developer can fix this defect later also. So the defect which has to be fixed but not immediately. This can specifically occurs during ad hoc testing, like we are testing ad hoc and we are breaking the system. Then we found any particular defect, and that particular defect can be a high severity but low priority. So let's say a particular functionality can be used by later version. So that is not needed in this particular module or in this particular cycle. Then that defect moves to the low priority but high severity because the functionality is needed but not immediately. Then we have the low severity and low priority. Like these kind of defects are the cosmetic defects, like the UI defects. Generally, cosmetic errors or dimension errors are in the table is called in as low severity and low priority defects or any UI issues. So in this section, we have seen what is the severity and priority, and we have seen the severity and priority with different examples. If x is greater than 50, then it is x large. So this is the statement to verify. So in this example, let's say we have yes while traversing through the statement coverage of the code, then we have the A, then we have the A1, B2 and C4. All the nodes should be covered. So by traveling through only one's path, all the nodes A, B, C, D, E are covered. Let's see this example, like we have read x and read y, two variables. So x plus y is greater than 10. This it is large. Else, if x is greater than 50, then it is x large. So what all statements we have? So we have the statement of like yes and no. So if read x is x plus 10, then it goes to yes condition. So the first coverage is x plus y greater than 10. So this is the first statement. If it is yes, then it is the second statement. And after that, if x and plus y is not greater than 10, then it goes to the third statement. And if it is greater than 50, then it moves to the x large. So it has the sixth statement, and the vice versa. If x is less than 50, then it moves to the end if for the other statement. So in this we have 8 statements as seen in this diagram. So in the statement coverage, we verify all the statements should be covered at least one. Then we have the branch coverage. So branch coverage covers both ways, like true and false both. So it covers all the possible outcomes of each condition at least once. So if it is pass, then it covers the statement 1. If it is fail, then it takes the other statement. To calculate the branch coverage, we find out the minimum number of paths which ensures the covering of all the edges. So now back to this diagram. In the branch coverage, like we verify the no condition also. So if in the statement coverage we verify the yes condition, but in the branch coverage we verify the no condition also. So we have more branches. So in the branch coverage we verify all the possible branches like true and false both should be covered at least once. So this was the example, like we have the x plus y greater than 100, then it is large. But let's take an example if x plus y is less than 100. So it moves to the branch coverage with the no condition. If x is greater than 50, then it is large, x large. But if x is less than 50, so in the branch coverage, it covers all the statement with yes and no both. So if the branches are tested properly, then we can see that all the statements are covered. Then we have the path coverage. So path coverage ensures that all the path is executed at least once. It ensures that every statement in the program is guaranteed to be executed at least one time. So path coverage ensures covering all the paths from beginning to end. In the example which is shown in the diagram, all the possible paths are like this: A1 to B3, then 5, then B7. So let's back to the diagram. Like now you can see it has A to B, then C, then after that D statement and E. So in the path coverage, it says all the paths of the different statement should be covered at least once. Then we have the condition coverage. In the condition coverage, it is related to the decision coverage. Like we have the AND condition or condition. So if we have the AND condition like A plus B greater than 50 and A plus C less than 100. So there is AND condition. So this is covered in the condition coverage. Multiple condition coverage is also known as condition combination coverage. Right? We have multiple condition. If we try to implement AND or condition both in one go. So this is the example of multiple condition coverage. So in this session, we have seen the white box testing technique like statement coverage, branch coverage, path coverage, condition coverage. Thanks for watching this session. SDLC. So what is SDLC? SDLC is a software development life cycle. That is, we also called it as a software development process. So we have different methodology for our STLC. We will see in our upcoming session. So the software development life cycle is a framework defining the task performed at each step in the software development process. Software development life cycle or software development process defines the steps, stages, and the phases in the building of a particular software, building a particular product. So let's see the STLC diagram. So STLC diagram says we start from the top side, like planning. After the planning, we define our goals. Then we design. After that, we build the software, and after the testing comes, and at the last we have the deployment of a particular product. So the software development life cycle includes the planning, defining, designing, building, testing, and the development, like the deployment of the product to the end client. So let's see what is all these phases. So in the planning module, we plan for our software building, like what we need, how we start. So this is done in the planning module. Then we define, like we design our framework, how we can start, what would be the manpower, how much team is needed. So all the things are used in this as a planning phase. Then it moves the defining, and we design our framework. Then we build the software. After that it goes to the testing. For the after the building it goes to the testing, like testing team test the application if it is correctly behaving as per the expectation, and at the last it moves to the deployment phase, like we deploy our application and it moves to the end user. So let's see which all models are available for the software development. Like we have various models. Let's start with the waterfall model. In the waterfall model, like we start from the planning and we have the testing at the last phase. Then we have the spiral model. Then we have the iterative and the incremental development, like unified process. So in the incremental, we give one particular module, then after that we increment something and we move to the different module. Then we have the agile development. Agile is implemented for each project in the current market scenarios where we have certain cycle like 15 days cycle, and we get certain features like multiple features, 2, 3 or 5 features for the 15 day cycle, and we have to build that particular feature in that particular cycle, test that and give to the end user. So we have the different development model like waterfall, spiral, incremental and the agile. In this session, we are going to see what is the life cycle of a testing and what we get in each stage. So, in the testing life cycle, we start with the requirement analysis. Like we get certain requirement. Then after that, we start the test planning. Then the test case development. After that, we set up the environment for our testing. Then we test execution, and after that we close our testing cycle. So this is our testing life cycle, like requirement analysis, test planning, test case design, environment setup, test execution, and the test closure activities. So let's see what we get in our each stage. So let's see what is requirement analysis phase and what is the exit criteria and what we deliver in this stage. So in the requirement analysis phase, the entry criteria is like we get the requirement document for the functional testing as well as the non-functional testing, and we get the acceptance criteria. We get all the architectural document for the project. So these documents should be there when we start our requirement analysis. In this, we do like we identify all the modules, we create the requirement traceability matrix like RTM, we identify the test environment, we start for our automation feasibility analysis. And what we deliver in this particular stage, we deliver the RTM, like requirement traceability matrix, and we give as an output the automation feasibility report. So once the requirement analysis is done, we give the RTM and we give the automation feasibility if it is applicable for the project. Then we move to the test planning. So what we do in the test planning? So in the test planning, we do the requirement document creation. We create the requirement traceability matrix. We get the test automation document. So in the test planning, we get certain documents like requirement document, traceability matrix, and the test automation. And what we deliver after this stage? We deliver the test plan and we deliver the effort estimation. You can see in the last pane, that is deliverables. So after the test planning, what we deliver to the client? So we deliver the test plan and the test strategy, and we deliver the effort estimation. So this is the deliverable for test planning phase. Then we move to the test case development. So as name suggests, the deliverable for the test case development is the test cases. We create our test case and we give to the client for the verification if we have written a correct test cases and we have covered all the features. Then we have the environment setup. So in the environment setup, like what is the entry criteria? The entry criteria is system design and architecture document. So we get all the document and we have the setup plan for all the environment, like automation environment or any particular tool we wanted. So all the things we set in this particular stage. And what is the deliverable for this stage? The deliverable is environment is ready for our test data. And we also verify the environment by running the smoke test. So smoke test is a small set of test cases, let's say 5 to 10 test cases, and we try to execute on that particular module on this particular environment so that we can see our environment is correctly behaving. Then we have the test execution phase. So test execution phase, like we baseline our traceability matrix, our test plan, our test cases. So all the data is available now for testing. Then we do the unit and integration test report. And what is the deliverable for this stage? The deliverable is the complete requirement traceability matrix with the execution status. Like we execute which all modules and what is the status for each module, like home, login, finance, like the payment page. So what is the status for each module? Then the deliverable is test cases is updated with the result, like with the defect report as well. Like if we have executed any particular test case and that is failed, then we have the report also for the defect. So the deliverable is the test case is updated and the report for the defects. Apart from that, RTM, that is requirement traceability matrix. After that, the last stage for the testing life cycle is test closure activities. So in the test closure activities, we have completed our testing, we have the testing result, we have the defect sheet. So the deliverable for the client is the test closure report with a different testing matrix, like the test cases pass fail, priority severity, the defect sheet. So these are the documents we deliver to the client after our test case closure activities. So in this session, we have seen the STLC, that is software testing life cycle, and the deliverables for each stage. In this session, we are going to see the defect life cycle and a defect format for our testing. So let's see the diagram for defect life cycle. You can see it is initiated when we start submitting our defect. So defect started with the new, then it is assigned to some team member, then it moves to the assigned status. So when we submit as a tester a new defect, then it is in the new status. After that, once it is assigned to a particular developer, then it is in the assigned status. After that, once that developer is started working on that particular defect, then he opens that defect. After that, he fixes that defect, then it moves to the fixed status. And after the fix is done, then he moves that status to the pending retest. So pending retest comes to the tester. Then tester moves that to the retest. After the retesting is done and it is successful, then it moves to the verified and the defect is closed. But once the retesting is done and it is failed again, then the tester reopen that. So it is moved to the reopened state from the retest. And after the reopened, it moved again to the developer for the opened state. So from the retesting, it can go to the reopen, and from reopen, developers again start working and it move that status to the open. And one more criteria, like once the defect is open for the developer, he can reject deferred, or he can mention that it is not a defect or it is a duplicate defect. So after it is open by the developer, then he can reject or defer. So deferred is a state like he can defer to some other cycle, like they are not fixing this defect as of now and they can fix it later, or they can mention it is a duplicate or it is rejected, like this functionality is not needed and it is not a defect, it is not a bug. So this is a life cycle of a particular defect that goes from new to closed status. Then I have attached a reporting format for a particular defect in an Excel sheet. So let's see this format. So this is the format of a particular defect, and inside it, like we have the defect, then what is the use case, detected in, like in the testing status, or it is the functional testing, or it is the implementation testing, production testing, at what stage it is received, then who has detected this defect, then the defect detecting date, then what is the defect type, like it is a coding or it is a UI, it is a design, it is an environment defect, it is a performance defect. So what kind of defect it is, then the severity of the defect, like it is a major or it is a critical or it is a minor defect. So priority and severity we will see in our upcoming session, because it is a different topic. Severity is something like set by the tester based on the requirement, like how much critical that functionality is. Then we have the priority. Priority is high, medium, low, or it is a urgent. So priority is set by the developer, like how soon they can fix this defect. Then we have the status, like what is the status of the defect, like new, closed, reopen, fixed. as we have seen in the diagram. Then we have description for that particular defect. Then who is the signed person? What is the resolution date for that particular defect? Then what is the resolution? Right? What was lacking and what the developer has fixed. So he gives the resolution. So this is the format of a particular format of a defect. We can use this format for our real project defect tracking. If we are not using any tool like SIDA, Spira, Quality Center, so we can raise our defect into Excel sheet, and this is the proper format how we can write the defect in Excel. So in this session, we have seen the defect life cycle and the defect format. In this session, we are going to see what is V-model and why we need V-model testing methodology. So, as seen in this diagram, we have the V-model that is used for the development as well as for the testing. So in this diagram, let's start from the bottom of the diagram. In the bottom you can see it has the coding. So once the coding is getting started, the first module that is for the development as well as for the testing is the module design. That is, unit testing is done for the module, then we have the unit testing for the tester's point of view. So in the left side of this diagram, we have module design, architecture design, system design, and the requirement analysis. So on the basis of these things, we have at the right side of your screen, unit testing, integration testing, system testing, and acceptance testing. So why V model is implemented? V model is integrated because the developer and the tester can start their work simultaneously. If the developer is doing the module design, then tester can start with the unit testing. If the developer is doing the architecture design, then tester can write integration testing test cases. After that, the developer started the system design and the tester can write system testing test cases, that is end-to-end testing. And at the last, the requirement analysis. And now for the requirement analysis, in the testing we have the acceptance testing, like that is done by our end user, end client. So V model came into the implementation, or you can say the testing, because it gives you the flexibility to start working with the development as well as the testing simultaneously. So both can work as per their module on the same thing. So same feature a developer can develop, and same feature the tester can start writing their test cases. So in the V model, tester and developer works simultaneously to see the validation and the verification that is available in testing. So what is validation? Validation is the process of evaluating the final product to verify whether it is meeting with the business need. So in a simple term, you can say what we do, our day-to-day life is actually the validation activity, which include the smoke testing, functional testing, regression testing, and system testing. So validation testing, verification, and valid system testing. So validation testing verifies if the product that is created is meeting with the expectation. Then we have the verification. In the validation part, are we building the right product? Like, what is the business need? And we have created that particular product. So that is checked in the validation part. In the verification, this is done without executing the software. In the validation, it is done with executing the software. In the verification, it involves all the static testing techniques. The static testing techniques we will see in our upcoming sessions. In the validation, we see the dynamic testing technique. In the verification, it includes like review, inspection, and walkthrough. It is basically a code review kind of thing. But in the validation part, we do smoke testing, regression testing, functional testing. So all kind of testing we do in our validation part. We wanted to see if we have created the correct product for the end user. So we have the different testing type errors. We have defect, we have error, we have bug, we have failure and fault. So what is a defect and the error? So let's start with, if we have any coding mistake, then we call it as a error. So error found by the tester is called a defect, and defect accepted by the development team, then it is called a bug, and build that does not meet the requirement, then it is a failure. So in the simple term, if developer has created any particular error, then it is a defect, and if the defect is accepted by that particular development team, then it is a bug, and a build that does not meet the expected criteria, then it is a failure. So defect is an error or a bug in the application which is created. A programmer, while designing and building the software, can make mistake or error. These mistakes or error means that there are flaws in the software. These are called as defects. So defect is basically a coding mistakes that is done by the developer. Then if our actual result is deviating from our expected result for the software or the product, then it is a defect. Hence, any deviation from the specification mentioned in the product is something like it is a bug or issue, incident or problem, whatever we can call it, it is a defect or a bug. If the functionality is deviating from a feature that is expected, then if the result of the software application does not meet by the end user expectation or the software requirement, then it is a bug or a defect. These defect also occurs because the error in some logic that is implemented by the development team that can cause to the application failure. So if a certain functionality that is implemented is not expected by the client and it is not as per their need, then it can cause a system failure. That is, we called it as our application failure or the product failure. So in this session, we have seen the different testing type errors and verification and the validation, what we should do in our real project testing. And this session, we are going to see the testing approaches that are available for the testing profile. So, what is a testing approach? A testing approach is a test strategy, you can say, for the project that defines how testing would be carried out, like how testing should go for the project. So there are two types of testing approaches available: proactive and reactive. A proactive is an approach in which test design process is initiated as early as possible in order to find and fix the defect before the build is created. And in a reactive approach, we are not started our testing until the design and the coding is completed. So we design our test cases once the development is done and we receive a particular build for a testing. So there are two kind of testing approaches: proactive and reactive. Then we have the different testing approaches like dynamic approach, consultative approach, and we have the model based approach that is used for statistical information about the failure rates. So we see on what kind of ratio our test cases are getting failed. Then we have the risk based testing approaches where the entire development tasks are based on the risk, like on the basis of any particular risk, like if our test cases are failed or our feature is goes down. So we take the approach of risk based testing. Then methodological approach, like which methodology you are using, like agile testing, waterfall model. So what kind of testing approach you are following? Then we have the standard compliant approach specified by industry specific standard like ISO, CMMI. So different kind of standard which is available in the industry, we take that and we follow that approach for our testing. So let's take the level of testing. So we have a different level for our testing. So let's take an example. So let's start with unit testing. So unit testing is basically done by a developer. Then we have the component testing. Component testing is also done by the developer. Like each component they test and they see if they can work that component with the integration testing. So next module is integration testing. In integration testing, we integrate the different modules or you can say component and we test that particular feature as one functionality, like we integrate couple of modules. Then we have the big bang integration, like it is also done by a developer with the integration of module or components. Then we have the top down. In the top down level of testing, we simulate the behavior of the lower level modules that are not yet integrated. Like we create a stub. Stub is a keyword basically. Stub we create for a different module and we test our functionality. It is a temporary replacement for that particular module. So let's say I'm on the home page and at the last of the page we have the contact us. So in the contact us, we create a stub for that and we try to create a temporary replacement and test our whole page as a top down approach. Then we have the bottom up. Bottom up is a vice versa of top down where we create the temporary module for our higher level. So that we called as bottom up approach. Then we have the component integration testing. In this example, basically the modules and the components are integrated. Then the testing is done with different module and different component that we called as component integration testing. This is the testing basically done to ensure that the code should not break after integrating two modules. Then we have SIT, that is system integration testing. System integration testing is where the tester basically tests that the same environment, all the related systems should maintain data integrity and can operate coordination with other systems. So in the system integration testing, as a tester, we test our application as one system. We test all the modules, all the features of the application, and we see if the data integrity is there. Then we have the acceptance testing, that is IUAT. Acceptance testing are basically done to ensure that the requirements of the specification are met. Then we have the alpha testing, beta testing. Alpha testing is done by the developer side. It is done at the end of development process. And we have the beta testing. Beta testing is done at the customer side when we give our application to the end user. Then it is done just before the launch of the product to ensure that all the features which is expecting in this particular module is working fine. So that is tested under beta testing. So in this session, we have seen the different approaches and the different level of testing that is available. In this session, we are going to see the test case design technique, how we can create the different test cases based on the available techniques. So we have a different kind of techniques like black box testing, white box testing, and others. So let's start with the black box testing techniques. In this, we have the specification derived test, equivalence partitioning, boundary value analysis, and state transition. So what is specification derived test? Specification derived tests are based on your requirement, like it is based on your specification document. So we create our test cases on the basis of your test that is mentioned in your specification document. Then we have the equivalence partitioning and boundary value analysis. So what is equivalence partitioning? It is basically a black box testing, as we have seen, which is applied for your all level of your testing, like unit testing, integration testing, or system testing. In this, we divide the input data of your software into two classes. One is valid, one is invalid, and we verify how it is behaving for different conditions. So in the equivalent partitioning, we verify the valid scenarios with the partition and the invalid scenario for the partition. Then we have the boundary value. Boundary value analysis says we should check the verification of a particular test case feature on the higher side, like on the peak point, and from the lower point. So let's say we have a range of testing an integer value of 10 to 15. So we should verify the peak point of 15 and 10, and in between we have to verify the 16 as well as the 9 also. So we are verifying the lower point as well as the upper point of the feature what we need to test. So in the boundary value, we verify if our corners are expected, the current value, if our corners are getting the exact values what it supposed to get. So in the boundary value analysis, we are testing our feature for the corner cases also. Then we have the state transition testing. So state transition is also a black box testing technique in which outputs are triggered by changing to the input. In other words, we can say like tests are designed to execute the valid and the invalid state transition. So in this, generally we give the input condition or we change the state of your system. So we change the state of the system and then we verify the certain features. So we execute the valid scenario as well as the invalid state transition. Then we have the white box testing techniques. Like we have the branch testing. In that we see if all the branches of the code is covered properly. Then we have the condition like if and else condition, while loop. So all the conditions should be met. Data definition use of testing, then the internal boundary value testing. So we test this in our code. Then we have the error guessing. Error guessing is nothing but a testing which a tester is doing based on his or her experience. We guess like in this feature, this could be the issue available while we are testing. So we guess a particular error and we try to find out if that is available or not. So it is completely depend on your tester's experience. So error guessing technique, we design our test cases based on the experience of a tester. So these kind of testing techniques are available like black box testing, white box testing and other. On that, based on these techniques, we create our test cases. So black box testing is creating the test cases by the tester. White box testing techniques, generally test cases created by developer to do their unit testing, and other is a different section. It is completely based on the tester's experience and they create certain test cases and that can be included in the black box testing. So in this session, we have seen which all kind of testing design test cases techniques are available and we can use as per our need while creating our test cases. In this session, we are going to see what is a test case and what should be the format of a proper test case. So let's start with the test case overview. A test case is a detailed procedure that is fully test a feature or an aspect of a feature. Like test case says what is the functionality and how we can test that in a detailed manner. It is a step-by-step plan of a particular feature. Like we say, if a test plan describes what to test, then test case describe how to perform a testing on particular functionality. We generally say we need to develop a test case for each test, like each functionality based on the test plan. So if we have 10 different functionality in a test plan which need to be tested, then we should have at least 10 test cases to test thoroughly that particular feature in our test case document. So test case says how we can verify a certain functionality by step information. So let's see a particular test case format which we generally follow for each functionality testing. So this is a testing structure. Let me open that. So this is a test case format for a particular project which I have shared here, like what should be included in the test case document to test a particular feature. So in this we should have a requirement ID, then the application name, then the subject say like what is the module, the test name like any feature which we are going to verify. Let's say I'm testing a home page, then it should be home page. Then the testing stage. So testing stage is nothing but what kind of stage of this, like unit testing, system testing, integration testing. So what kind of testing stage this is. Then after the testing stage, we should have a description of the test case, like what it says. I am just for example written over here, verify the feature 1. So we can mention that verify the login page, or we can mention verify the username, verify the password field, verify the login button. So this should be mentioned in this particular description. Then what is the expected result for this particular feature? So if we are testing the login page, then our expected behavior is user should be able to log in successfully. So expected feature says what should be our expected behavior for a particular functionality when we are testing with step-by-step information. Then we have the step type. Step type is a description for step-by-step information. So let's say I'm testing a login page, then we should have user move to the login page, user enter the username, then user enter the password, click on the login button. So this is the testing step for a login page. So this is how you give your step type. Then we have the status. Status is like when we are executing this test case, then what is the status, like it is passed, it is failed, it is in progress, it is not run, it is blocked, or it is a future functionality. So what is the status for this particular test case? Then the type of the test case, like it is a manual or it is a automation type test case. So this is included in the test case. Then we have the severity, like how severe this functionality, like S1 critical, medium, low. So severity 1, 2, 3 and 4. So I have included as per my project. You can include the severity, type, status as per your project need. Then we executed on. So this is the date, like if we are executing today, then we can give 0 to 12 2016. Then if we have any particular special comment, like it is depend on some other feature, it is depend on some other particular environment, if it is not executed, then we can give this special comment over here. Or if we have logged a defect for this testing, then we should enter a defect number in the comments. So this is how our test case should be proper formatted, like requirement ID, application, subject, test name, stage name, then we have the description, then after the description we have the expected, then we have the step by step, then we have the status, after that type, severity, executed on. So this is the proper test case format which is taken from the real project on which we are working. So let's say we have different modules. So I have here taken as an admin, then I have taken as a customer module. So same thing is mentioned over here. This I wanted to show you because I wanted to include these two modules in our status sheet. So this is my status sheet and you can look into it like how I have differentiated. So I have functionality wise like it is admin and it is customer module. So how many is passed, how many is fail, I have created a formula for each column like it is taking directly from the admin module. So let's say I wanted to fail the test case. So if I fail, so now you can see all three are failed. So my test case status should be 3 fail, like there is no pass test case. So it is automatically taking from the different sheets. So status is mentioned properly because this is what your client would be see. Then I have taken a status based on the automation and manual test cases. So if I have created a automation and manual both test cases, then we should have a proper number so that our client can see how many test cases from each module is automated and how many is manual. Then I have taken the issue pending, like if I have logged a defect like it is a severity 1, severity 2, severity 3 test case. So on the basis of your test case severity, I have created the status. So it is basically taken from the real environment, like how we can create a good status for your test cases so that each and every person can view it properly. And I have created a different formula for each column so that it should take directly from the sheet. Now you can see it is taking the formula for the each sheet, for the each functionality it is taking the formula. So I have taken on the base of status, type, severity. So every kind of status for my test case I have taken in the status sheet so that our client, our management can see properly. So this is the way we should create a good proper test case format. So let's move to our slide. So I have shown you what should be the proper test case structure we should use for our real project. It is basically created differently and in a different you can say company. So as per your need, we should use a proper format with the proper status sheet for our test case format sheet and status. Thanks for in this session we are going to see which kind of non-functional testing are available and what we do in our project or application. So let's take the non-functional types which are available. So we have the first testing type, that is software performance testing. So performance testing comes under non-functional testing. In this, we check the speed and the effectiveness of your application. Like, let's say we are testing our application for 1 user per second, but let's say if our application is a shopping application and in the festival season we have a good amount of load in our application site. So on that particular time, we give some performance testing, like if we put some load, so what would be the speed, and if the correct output that is expected is coming or not. So that is tested under performance testing. Then we have compatibility testing. So compatibility testing means we verify if our product or application is compatible with different operating system and different browsers. So let's say we have created our application on the Windows platform and we are working on the Chrome browser, but our end user is working on Unix machine, Mac machine. They have different browsers like Safari, IE. So what is the compatibility of our application with the different platform? So that is tested under compatibility testing. Then we have the load and stress testing. So load and stress testing is the part of our performance testing. So in this, we give the normal load and the peak time load. So what is peak time load? Peak time is like, as I have explained earlier, if our application is a shopping site, then on the peak time, let's say on the festival season, if good amount of load is putting into our application, so what should be the behavior? Our application should not go down and it should behave as expected. So that is tested under load and stress testing. Then we have the internationalization and localization testing. These testing comes under non-functional testing. So in this, we generally verify if our environment got changed. Let's say I'm in India and our application is also getting open in Europe, or you can say America. So the application behavior should not got changed. Like if that goes on some other domain, some other country, so the text should not got changed and that should behave as per that country. So this is tested under localization testing. For this, we have different of libraries available so that we can verify if our application is getting open in Europe. So our application behavior should be good enough. Then we have the recovery testing and failover testing. So these kind of testing is comes under non-functional testing. Like if we have any risk, our application is crashed or our application goes down. So what could be the behavior? So what could be the behavior in any particular risk arrives? That is tested under recovery testing. Then we have the accessibility testing including compliance with. So what is accessibility testing? Accessibility testing we do generally for the disabled person. So let's say any particular disabled person want to open the application, so how he can verify at what page he is. So there is a functionality of accessibility which we can work on, and so that disabled person can also open our application and work accordingly. Then we have the availability testing. So availability testing says our application should be available enough for every time when the user is getting open that particular website. Then we have the documentation testing. So documentation testing is something like we create different documents while the testing, like we create test plan, test strategy, test cases, defects with a different priority. So these kind of documents are tested under the documentation testing. So our document should be proper enough so that client can see them and they can think of what is implemented in the application. Then we have the maintainability testing. So in the maintainability testing, like how we are maintaining our application. Like once the testing and the development part is done, so what could be the behavior in the maintenance phase? How our maintenance phase will go on, and once the application is deployed for the real environment, so after the real environment, how it will maintain. So this comes under the maintainability testing. Then we have the reliability testing, volume testing, like how reliable our application is. Can we rely on certain functionality? So how this can be done once the application is goes down. The volume testing says like we are giving lot of volume, lot of hits to our application, and this should behave properly as it is in the normal time. So these kind of testing comes under non-functional testing. So in this session we have seen several non-functional testing and what they all are about, and we have seen the definition of these non-functional types. In this session, we are going to cover what type of testing are available and what kind of testing we generally do while working on our product or our application. So basically we have two types of testing which we generally do for our project, that is functional testing and non-functional testing. So in this session we will cover which all are available for functional testing and which all are available for non-functional testing. So let's start with functional testing. So in the functional testing, let's start with the GUI testing, that is graphical user interface testing. So what we do in this testing, when we are testing the GUI, then we generally see like if the menus are correctly available, if the buttons, the icons, or you can say the bars, toolbar, menu bar, or the dialog boxes. So all the interface of the application is displaying correctly on your web page. We also see like the font, color. So all kind of these testing is done in the graphical user interface testing. Then we have the usability testing. Usability testing is a part of your functional testing. So what we do in this testing? So in the usability testing, we do how easy it is available for the user. Like when user is working on the application, how easily they can adapt in the application. So the easiness is checked in the usability testing. Like the buttons are available at the proper side, the menus are properly aligned, it is well formatted, or you can say it is well sorted, alphabetically sorted. So easiness of the user is checked in the usability testing. Then we have the installation part, like the installation testing, or you can say the implementation testing. So what is installation testing? So in the installation testing, we generally check the installation part. Like if we click on the next button, the what kind of the interface would come, and the setup, the exe or the library, whatever is available in the setup file, it is properly picked and it is accordingly checked into the path. Like we have seen, let's say we are installing the Java. So when we click on the next button, so let's take an example. If we are installing Java, then what we generally do, we double click on the exe file and on the next screen it is automatically take the C users path like C program files Java. So this is all checked in the installation part, installation testing, like if the proper path is getting picked. Then we have the regression testing and the retesting. Regression testing is basically a testing when we see if our all the existing functionality is correctly working after deploying the new build, or you can say implementing a new functionality. So in the regression testing, we generally check if our existing functionalities are working after deploying the new functionalities. And the retesting is the testing when we have fixed any defect and then we check if it is working as expected after executing the same steps what we have followed earlier when logging that defect or following that path to verify that particular functionality. Then we have the smoke testing and sanity testing. So next we have the smoke testing and sanity testing. So smoke testing is basically performed to verify if the critical functionality of the program, or you can say the application, is working fine. Then we have the sanity testing. So what is sanity testing? Sanity testing is basically, you can say, it is a build testing. Like if we receive a particular build, a change like with a certain functionality is implemented in the in that particular build, then we verify if after including that functionality all the existing functionalities are working fine, and we test like if the bug is fixed and there is no issue, like there is no new issue is introduced after including that particular functionality. Then we have the installation testing. Installation testing we have covered in the implementation and installation part. So let's take the other functional testing, that is unit testing. So unit testing is the testing which is done by the developer to test a particular module, a particular functionality you can say. Then we have the integration testing. In the integration testing, we integrate two modules. Let's say home page, login page. So these kind of modules are verified in one. Like we integrate couple of modules and then we test our application. Then we have system testing. System testing is basically a end-to-end testing of the application. So this is the part of your functional testing types. Then we have the UAT testing. UAT is nothing but a user acceptance testing. It is generally done by the client or by the end user. So we have a different team for the UAT testing. In this, we test like how it is working for our real users, you can say, or you can say for the real end client. Then we have the exploratory testing. Exploratory testing is nothing but a testing which we do for our application without having any particular test cases, and we generally explore the application. We are not aware of the application, not aware of the functionality, so we are exploring the application. We travel to the different pages of the application and find out the behavior of the application, and we check how it should behave. Then we have the ad hoc testing. Ad hoc testing is also a kind of, you can say, exploratory testing where we don't have any particular fixed way for the testing. In the ad hoc testing, we move from one page to other page and do the testing and give the final output to the client. So these are the functional testing types that are available, and we generally do this kind of testing without awareness like what kind of testing we are doing. So in this session we have seen which all types of testing we do as a functional part.